situation, don't have a greater potential anymore. Now when we hit that, when all those dominoes falling, that's a what? Action potential. Okay? Huge change in potential of the membrane where it goes so far to positive now. All right? To positive. All right? It's going to try to reach 60. You know why 60? Because sodium's equilibrium potential, if you read that, all right, I'm not going to get too much into that. All you need to know is that at an equilibrium potential for a particular ion, that's when the ion no longer has that concentration gradient. No longer is he going to be going from what? High concentration to low. It's like both concentrations in both solutions, right? So he's not moving at all at that point. All right? And so, yes, he's going to try to reach positive 60, but he doesn't get there. He gets to about what? Plus 40 or so. All the way up there. That represents what we call an action potential. That type of depolarization where he goes all the way up like that represents what we call a what? An action potential. But see, our action potential is going to have different phases, okay? Our action potential is going to have what? Different phases. Very good. So that's just the first phase. What do we see just now? We saw the first phase of an action potential. Where is an action potential going to be? Is it going to be at the dendrite? At the dendrite? It could be. We'll get to that later, but most of the time it's at the what? Axle. Got that? It's at the what? Okay. And by what kind of channels? What kind of channels are creating that? Is it mechanical gated channels? No. Is it ligand gated channels? No. For action potential is what kind of channels? Voltage what? Gated ion channels. Okay? There it goes. Repeat. Okay? That's what you write down in the notes. Okay? Yeah, the difference between where you would have a graded, what? A graded potential. What kind of channels cause a graded potential? Your mechanical gated ion and your what? Ligand gated channel. But what creates the action potential? What kind of channels? Voltage gated. Very good. Voltage gated ion channels. Okay? That's who does the domino effect. That's who creates not a slight change in membrane potential, but a what kind of change? Huge change. Major change. Goes all the way up to plus 40. Close to that sodium's equilibrium potential, where he wouldn't even move anymore. He wouldn't even come into the cell anymore. Going really close to that, not quite there. Okay? This is huge. Now we got the inside of the cell mostly positive. Inside of the cell mostly positive. Okay? This is the first phase of what we call a what? Not a greater potential, but a what? The first phase of a what? Action potential. All right, look. So basically, when we're looking at what we got now, which is called the action potential, we see then that before channels have opened, they're at what? What's the membrane potential? Negative what? 7. Starts there. But when you have this action potential, no slight change in going positive, a great change in going positive. You see that? What's it as a result of? Sodium rushing in to the cell. Is that right? Very good. Now what we're going to do is this. This is what's happening here. We're just going to pay attention to the fact that, and I don't want to lose you here. Just check this piece. This is it. Watch it. Watch it. sodium channels, okay, they have two different types. The sodium channel goes through something, okay, where now he's activated, and that's what we saw. But then they have what you call what? Inactivated gates, okay? These channels are going to go through what we call what? An inactivation process when it goes up to about that plus 30, plus 40 range. Okay? What does that mean now? If it's going to become inactivated, the gate's no longer going to be what? Open. What happens to the gate? Closes. Okay? It's just that's the way it happens. Okay? As soon as you have these gates open, it's going to be the short time frame when now these inactivation gates are going to click in. Boom! Closing up the channel. And no longer can you have your sodium rushing in the cell. Where is that going to happen? It's going to happen right there when you get to around plus 30, plus 40. Okay? All right, now, this is what's important. Let's make sure we understand this. I didn't really get into this on Monday. Watch this, okay? Listen to me. In that same location where sodium channels open because of the what? Negative 55 threshold. There were some other channels that opened up as well. Right there next to those sodium channels, you have, right next to sodium voltage gated channel, you have potassium gated channel. Did you hear that? At the same time, the sodium opened up. What else opened up? Yes. Right next to these sodium were what? Potassium gated channel. Now, I'm going to ask you this. Where is potassium mostly? Is it mostly outside the cell? It's mostly where? Inside the cell. Okay? It's mostly where? Inside the cell. That's the difference, right? Most of sodium is where? Outside the cell. So he's going to actually go where? Where is he going to move? He's not going to move outside. Sodium's not going to move outside. If most of sodium is outside, then he's going to move where? Where he's at a lower concentration. If you have most potassium inside the cell than outside, and his channel opens, where is potassium going to go? Beautiful. His flux, his movement is going to be where? From inside the cell to where? Yes. Okay. Now, if he does that, and what's potassium's charge? It's positive. If you have more positive leaving the cell, does that make the cell more positive or less positive? There you go. Is that simple? When potassium is in flux, which is what he always wants to do. What does he want to do? Go from high concentration to low. What is that movement? It's from the inside of the cell out. Is that right? Whenever potassium's in his flux, he causes the cell to become more what? More positive. Does he cause the cell to become more positive when he's in flux, which is going from high concentration to low? Potassium is leaving the cell, and he's a positive charge. So if potassium's leaving the cell, is he making the cell more positive, more negative, or is he keeping it the same? He's making it more negative. Okay. Whenever potassium is in flux, whenever he's going from high concentration to low, which is leaving the cell, whenever potassium is leaving the cell, the inner membrane becomes more what? Got it? That was the difference. The opposite is the situation with sodium. Okay? We got that? Now we have an issue here, don't we? If sodium and potassium are opening up at the same time that the cell witnesses what? A negative 55 millivolt. Yeah. he goes through the domino effect too, right? They're voltage gated channels, right? We have an issue here. If you have sodium and potassium channels open, how is it that now the cell becomes more positive if potassium's leaving the cell? Well, if sodium rushes in, yes, that makes the cell positive. But if potassium leaves the cell, doesn't he make the cell negative? It's not more sodium coming in. Same amount of channels. So who's the hero here?
Oh, calcium?
No, calcium's not involved yet unless we talk about the heart and at the end of an actual neuron. Well, nobody.
The pump?
Oh, listen. At the same time these channels open, it's just that somebody's a slowpoke. Somebody's the turtle in this race, okay? Who's the slowpoke? Who's the one that's opening up slow? Potassium. Okay, so that's why the cell becomes incredibly positive first, right? But as soon as those sodium channels close because of the inactivation gates at plus 30, now who's all the way open? Potassium channels. See, they opened up late, okay? So as soon as we get the plus 30, you're going to have now what? Potassiums, all those channels are going to be now open, right? And then you're going to have what now? The cell turn into what? Is it going to be still positive inside the cell? No, it's going to become more what? Negative. It becomes more negative, all right? Now what you're going to have now? You're going to have now the situation, it's going to start to go back to what it was before. What are you going to have? You're going to have now the cell, the inner membrane, more what? Okay, more negative in the inside, but more what on the outside? So now you're going back to the polarity that you were before. Is that right? If you go back to the polarity you were before, then what's the English diction prefix for that? Re. You're going back to. Is that right? You're going back to the polarity you started with. So what do we call that phase of action potential? When those potassium gates are finally open, finally they're here, and now they can let the potassium out? That's repolarization. Okay? Who's first in this action potential process? Depolarization. Because those sodium channels were open. Boom. They took off. What happened? Sodium did what? Did it leave the cell? No, sodium was what? Rushing in the cell. Okay? That's the depolarization phase. Is that right? But then, inactivation gates of sodium close. No longer can sodium make the cell positive. It stops at that plus 30, plus 40. But who's all the way open now? What kind of channels? Potassium. And now what? Potassium rushes in the cell? Potassium rushes in the cell? It comes out of the cell, okay? Because he's a higher concentration in the cell than out. That means he's going to deal with the laws of nature and tip. He goes from high concentration to low, okay? And if that's the case, you got positive leaving the cell. What does that make the cell? More what in the inside? If it makes it more negative in the inside, yes. Now we're going back to what the resting membrane potential was. Isn't that right? We're going back to negative 70. We're headed toward negative 70 again. Is that right? Yes. We actually go back then. You see that? Going back then. What is that phase of action potential called? When you go back to the polarity it was before? Repolarization. Okay? All right. Only problem is this. Our potassium here, we got to negative 70, and our potassium channels were slow to open. So what are they going to be with respect to closing? Are they going to close quickly? No, they're going to close what? If they close slow, once you get to negative 70, they're not all the way closed, are they? No. So you're going to have this what? Excess potassium coming out. Is that right? Excess potassium